Hello everyone. In this video, I will demonstrate how to do the lab 6, where the lab 6 is pipeline for performance. So I will demonstrate how to use the pipeline to increase the performance of your design, FPGA design. In lab 6, we have 1, 2, 3, 4, 5 C code, and also 3 test data. In this lab work, we will do the color filtering, convert the color from RGB to YUV. And in this source code, C code, there are three function in here. The top function is RGB to YUV. This is the top function, and for the function, but for the sub function, there are three sub function in here. The first one is RGB to YUV. The second one is YUV to RGB in here, and the last one is YUV scale. And for the test, for the test, uh, for the test is reading the image in here, image from the test pen. The image read is on in here, image aux. In image aux, there are two functions, read and write the image. For the test, after read the image, they will convert or filter using YUV filter. After filtering, they will be write the image. They will be write the image and compare it with the test data, then output data. If the return is not same, they will give the notification that test is filed. And after finish, or there is no mistake in filtering, they will show the test is passed in here. For the tool command line, the tool command line will be call all the function in here. They will be called, this is our device design, FPGA design. The main design is YUV filter. And doing the test pen in here, there are three test pen in here. The first one is call the image read and write in here function. The second one will be test using YUV filter test that all of mine test in here, read, filter and write, and also compare it. And the last one is called the image data, test data. And then we will set the pipeline is off first. So we will compare if the design not using the pipeline, and how about if we using the pipeline, do the performance is increased or not. The first step you need to do is open the vdis command prompt and go to this directory, cd, enter, and run the TCL command. Run YUV filter. Okay, this TCL file will make the YUV filter project folder, and now doing the C simulation test in here. They still load the image test data and do the filtering. And now the simulation is done. The simulation is passed in here. Test is passed. And the last one is doing the C synthesize. Last one is doing the C synthesize. After C simulation design, for the synthesize, it turn off the pipeline in here. Now we will open the project to see how about the performance. It is we will open the YUV filter project. YUV filter project. Okay, after the UI of our project is open, you can check the synthesize report. YUV filter synthesize report. In this report, you will see how estimate how about the number or the time clock in here. But in the latency, you cannot see the latency in here. Why? Because in our design, there are 3 loops in here. 3 loops. The first one is converting RGB to YUV. These loops depends on the width, where the width is the variable. So they cannot count how many cycle in here because width is depend on your image. So the design cannot count how many loops we're doing the RGB to YUV function. If you want to know to measure the performance, you should limit it the loop function. You should limit it the loop function. As you can see here, the comment the comment in here still not active, so we will uncomment in here. If we are using this command, we will limit it the cycle or trip count in here. we limited the minimum loop count is 200 and the highest is 100 1920. This means you can do the filtering with the image size minimum is 200 pixel and the highest one is 1920 pixel. So the size should be, the maximum is 1900 times by 1200. This is the maximum pixel size that you can convert using the uh, this function RGB to YUV filtering. So we will activate this command. We will activate this command. Now save this C function. Save this C function. So we will limited the size of the image that will be converted to 200 is the minimum size. The maximum size is 1200 times by 100 1900. Now we will synthesize it using active solution. And you can see the report again in here. Report YUV filter synthesize. Now you can see the latency is the minimum is 2 cycle, the maximum is about 36 million cycle, and for the maximum time is from 220 nanosecond up to 0.3 second. This is if we limited the YUV cycle count or trip count from 200 to 1900 cycle count. Now we will doing the pipeline in here. We will doing the pipeline. This is as our benchmark. Now we will turn off the inline because in here we will use the pipeline, so not using the inline. Inline is just one line, just the serial design, serial device design trip count, and we will turn on the pipeline. You should turn on all of the pipeline in here. The pipeline is still off. We will uncomment. So now the pipeline is on RGB to YUV function. And for YUV to RGB function, we will turn on to the pipeline. And the last one is, yeah. Oh, don't forget to use the pipeline from X loop and Y loop in here. Okay, make sure that all pipeline from RGB to YUV function is on. On the pipeline on. Okay, all the pipeline is on. Now make a new solution. Finish. Check again. Okay, the pipeline is on. Now the active solution is solution 2. Run the solution, synthesize the solution. After the synthesize is done, you can check the report by compare. We will compare the report from solution 1 to the solution 2. Solution 2 and the solution 1. We will compare and okay. Now you can see that the second solution have the maximum latency lowest than the solution 1. The lowest. This is the maximum latency that we can reach using the pipeline. And you can see for the time latency from 2.4 millisecond to 0.1 second. For the maximum latency, as you can see here, the solution 2 with the pipeline is lowest than the solution 1. And for the cycle, it will be limited because we limited the trip count and using the pipeline. So the cycle is minimum than the solution 1. But we use many resource in here. Many lookup table in here, LUT. The solution 2 using 2400 lookup table in here compared to the solution without the pipeline only use 1800 lookup table in here. So we have used the pipeline, and for the pipeline it will be increase the performance of the FPGA design, but using the many lookup table in here for optimize your design. And this is the end of the lab 6 project. See you in the next video.